Okay, this is example 9.5 from the book. This is actually pretty, well, it looks like pretty straightforward until you start doing it and you realize there's a few little, I don't know, iterations, little complications to it, but it's very doable. We're supposed to determine the moment of inertia of this shape with respect to the x-axis, right? With respect to this axis. So what is this shape? This is a composite shape. So what do we know? This is really, I'm going to not draw it to scale. It's this big block, right? Minus this little semicircle, or sorry, it's this true semicircle there. We'll call this 1 and we'll call this 2. Okay, so what do we know about Ix? Ix1. So we know Ix is just the sum of the two, right? It's going to be the one minus the other. So Ix1 is just, it's 1/3 bh cubed. Well, since we're looking for Ix with respect to this axis right here, the base is going to be 1/3. The base is going to be 240, and the height is 120 cubed. So Ix of this first one is simply 138.2 times 10 to the 6th millimeters to the 4th. Okay, so that was the easy part. Now, we got to figure out this half circle right here. So this half circle I drew poorly, so let's clean this up a little bit, see if we can make this make a little more sense. This half circle, go back, okay, is a half circle like this. Okay, so what do we know about it? Well, Ix is, we'll call it 2, is Ix2 bar plus d squared a. Well, do we know what Ix2 bar is? Well, we're going to go look it up, right? We're going to come look at the back of the book in the little table. Okay, so here we are in the back of the book, and we have this table for a semicircle right here. So Ix, so yeah, so right, we have this right here, and it's 1/8 pi r to the 4th. But notice, what is that? That's with respect to this axis, to the x-axis as shown here. But when you're using the parallel axis theorem, you must never do this, right? Because with the parallel axis theorem, it's only with respect to the axis that passes through the centroid. Again, why do we know that? Because that middle term, the first moment, does not go away unless you're passing through the centroid. So we know that the value through here, we can use that to determine the value through here. And once we have that, then we can turn around and use that to determine the whole thing. So let's look at it. I'm going to call this x prime. So I'm going to say Ix prime is equal to Ix bar plus d squared a, right? So I know what that is, right? I just looked it up. That is given to us as pi over 8 r to the 4th, I believe. Yep, pi over 8 r to the 4th is but that is equal to Ix bar, which is what we're actually looking for. But we do know this is d squared a. What is this? The a is simply 1/2 pi r squared, right? And what is the distance? Well, the distance is from this centroid to this line right here. Well, we know that. We look it up in the book as well, and that is 4r over 3 pi is that distance, and that's from the. Here, I'll bring that up real quick just so that everyone can be convinced that that's the right answer. Again, in the back of the book, we have this half circle of an area, and we notice that the x bar y bar is 4r over 3 pi. So that's where we get that number from. Okay, so coming back to here, therefore, Ix bar, is pi over 8 r to the 4th. I'm going to bring this over, so minus 1/2, well, I'll just bring this, so 4r cubed over 6 pi. I goofed up somewhere. Oh, I know where I goofed up. This is our area. This is our distance, so we need to square that. So scratch that, actually. We'll clean this up a little bit. So, give me that back, please. Thank you. So we have pi r to the squared over 2 times, in this case, 16r squared over 9 pi squared. So it turns out that Ix bar is equal to pi over 8 r to the 4th minus, and then when you do the math here, this cancels, 16 over 18 is 8 over 9 pi r to the 4th. So you can pull the r to the 4ths out, and so you say r to the 4th pi over 8 minus 8 over 9 pi. And that gives you an actual just number, because these are actually given with numbers here, and that gives us the value of 7.20 times 10 to the 6th, and that's millimeters to the 4th. Okay, so now we know Ix bar. We don't care about Ix bar, but we have to use it in order to figure out the Ix. So Ix2, going back to what we were trying to do right here, right, is sorry, that's not Ix2, it's not Ix squared. Get rid of that. Ix2 is really Ix2 bar plus d squared a. So that number, we just figured this one out, it's 7.20 times 10 to the 6th plus d squared. Now we're going from here to the centroid here, and so we figured out it's going to be 120 minus the 4r over 3 pi, but again, that's the distance squared, and the area is the 1/2 pi r squared. So Ix2 ends up giving you 92.3 times 10 to the 6th millimeters to the 4th. But lest we forget what we were actually trying to do, we are not trying to find Ix1 or Ix2, we were trying to find Ix. And remember, this is a positive, this area we're adding, and this is a negative area. So really, Ix is Ix1 minus Ix2. So it's 138.2 times 10 to the 6th minus 92.3 times 10 to the 6th. So the Ix of the whole thing ends up being 45.9 times 10 to the 6th millimeters to the 4th. So this is a good example. This one, pretty straightforward. Now you notice I didn't use 1/12. If I could have done 1/12, right? I could have, here, let's just for giggles so that everyone can see it. 1/12 b h cubed, right? And then plus d squared times a. So in this case, it's going to be 1/12 times the base, which is 120. No, sorry, the base is 240, and the height is 120 cubed. But now we are actually moving it, and we're moving it how much? A distance of 60. So it's going to be 60 squared times 120 times, 240. And you'll see that it's the same number as the 138.2. So we use, because we know we're just going from this axis, we can use a 1/3. So 1/3 bh cubed. But then over here, this one became a lot more complicated, because if you're going to use the parallel axis theorem, you must do it from the centroid of the object. And we're not given that number. The table, for as useful as it is, sometimes it doesn't give you those numbers. And so remember, this first step, this first little bit, is all about figuring out what is, up to this point right here, what is this Ix bar? What is this the Ix at this centroid? And then we can turn around and use that right here, what we did here, with the parallel axis theorem to determine the total Ix. And so it's not a hard problem, but it's a little more complicated. You got to make sure you're keeping track of that, and please use this example to remember that you can't just use any numbers. You have to be using the parallel axis theorem with the value through the centroid of the problem, or sorry, through the centroid of the shape.